Hey, welcome back. So in this video, I thought I'd talk about TurboPack. Now, if you've never heard of TurboPack before, that's okay because it's actually super brand new. It's created by Vercel, who are the same folks that created Next.JS. And in fact, the creator of TurboPack is the same creator who created Webpack in the first place. So you can guess what TurboPack's going to be. It's a faster version of Webpack. And actually, Vercel has made some huge claims which are really causing huge amount of excitement within the industry, which is TurboPack is actually 10 times faster than Vite. So what are we going to do in this video? Well, I'll show you how to get started with TurboPack, but we'll test out that claim and see how fast TurboPack really is in comparison to Vite. Okay, so before we actually test out how fast TurboPack is, we actually need to get a little bit familiar with it. So if you go to turbo.build/pack, then that's going to bring you to the TurboPack website. And of course, as I said before, TurboPack is created by Vercel. And as you can see, there is the Rust-powered successor to Webpack. So the major reason that it's going to run faster than Webpack is, of course, it's built upon Rust. And if you've seen any of my previous videos before, one of the things that I've said is that all JavaScript tooling is going to be replaced by more native alternatives rather than being built on JavaScript, TypeScript. And Rust is probably the primary tooling mechanism for that. And you can kind of see that, and that's very much part of Vercel's strategy. So TurboPack is created in Rust. There is a nice little sort of getting started guide. And actually, if I go a little bit further down, you can kind of see some of the claims that is going on here. So you can see there, it's saying TurboPack is with Next.js is a lot faster than Next.js 12. It's faster than Next.js 11, and you can see according on cold start, it's substantially faster than Vite according to the claims there. And then probably the test we're going to focus on is hot module reloads. So you can kind of see here the Next.js 13, again, substantially faster than Vite over kind of React Components 1000. Okay, so we will, that's the claim we're going to specifically test out. But before we do that, what we're going to do is show you how to get started. So if you click on the get started here, there's a kind of quick start guide there, so you can kind of see that you can do an npx create next app example with TurboPack. So actually, we will just do that very, very quickly, and we'll get it up and running, and then we'll show you how it works. And then once you're comfortable with that, then we're going to create a nice little test harness and put it up against Vite. So if I just type in npx create next app, and then we'll use dash example with TurboPack, but I will show you how you can actually just manually modify it a little bit later, so you don't need to use the example. So if we just run that for a second, it's going to ask for a project name. So we will just say first and next app, and then it will download the files, and it'll take a second there. Alrighty, so you can see that that's now installed. So if I just do an ls, you can see first next app. I can cd into that. Let's clear my screen. And then if I want to get started with that, I could just type in yarn dev. And as you can see, that's already sort of started up. And then if I click on the URL here, localhost 3000, you can see it's opened me up a sort of standard page, and I can just click on there. And as you can see, it's actually fairly fast. I mean, first thing that I want to say there is I'm clicking around on this, and it's a Next.js app. It's server-side rendered. It's pretty fast, and I'm kind of okay with that. So we'll just stop that for a second. Let's open up the code. We'll go through the code very, very quickly, and then we'll start going a little bit more detail. So as you can kind of see there's a couple of things I want you to be aware of, which is probably important, is in order to use sort of TurboPack, there's a few things that are different. They're using this sort of experimental mode here. You see experimental app directory is true. So there's a sort of change in Next.js 13 where they're having the support for the app folder and using pages. If I were to go to my package.json for a second, and then what you're going to see there is next dev, and then you see this -- turbo. That -- turbo is actually what is telling Next to use TurboPack when it's doing all the bundling, etc. So that is probably the key things. As I'm going to prove to you a little bit later on, it's using SWC as its compiler, which is a Rust-based compiler underneath that rather than using things like Babel, etc. So that's fine. Alright, so now that we've seen how easy it is to get started with TurboPack, what we're going to do is get rid of that application we just created. So it's going to say goodbye. And then what we're going to do is we're going to create from scratch rather than use the example. We're going to build up our own little test application that we can then use both in Next.js and in Vite, and then we'll build up our test harness around that to check how fast it actually is. Okay, so now that we've got rid of that, let's create our new sample application, which we're going to use to test these benchmarks, and we'll recreate that in Vite a little bit later on. So rather than using the example project, we're going to build it up from scratch. So to do that, all we're going to do is type in npx create next app at latest, and that's just going to pull the latest version of the create next app, which in turn will give us Next.js 13. And of course, we'll need to manually change it to use TurboPack, but that's fine. I'll show you how to do that. So we'll just run that for a second, and it's going to ask me what my project name is going to be. So we're going to call it Next Test App. And then it's going to ask me to use TypeScript with this project or not. In all honesty, all the tests that Vercel did and the ones that Evan You did, and I'll talk about that in a second, were all done using JavaScript. Now, I have tested this with TypeScript. There is really negligible difference, but in order to make things less complicated, we are just going to use JavaScript. But you know, if you want to use TypeScript, the same results sort of apply. Do you want to use ESLint with this project? No, I don't care about linting. Actually, in one of my upcoming videos, I'm going to do something on Rome later on, so you know that will be something to look forward to. And as you can see, it's going to go and create my next app. Okay, so now that that's created, what I'm going to do is we're just going to cd into my next test app. And then if we just open that up in Visual Studio Code for a second, what you're going to see there is it's created a little bit of a boilerplate. It's not as big as the other one, but what we're going to do is just get rid of all of that boilerplate, and then we will build up our own application. So I'm going to get rid of pages for just now, so I don't need that. So we're just going to move that to trash. I'm going to get rid of public, so we're going to move that to trash as well. I'm going to get rid of styles. So I'll open up our package JSON, and then what I'm going to do is just change that dev script so that it's going to use TurboPack instead. And to do that, I just do --turbo. So we'll save that. And now what I want to do is I'm going to recreate that app folder structure that we saw earlier. So I'll just create a folder called app. And then what I'm going to do is create a new file, and I'm going to call it page.jsx. And then within that, we'll just do an export default function. We'll call it hello, and then all we're going to do here is write a hello world. So we'll just do div hello world, and then we will close that off. We'll just save that and we're good to go. Okay, so now that I've made the my new component, it's just going to return me a hello world. What I'm going to do is I'm going to go into my next config, and what I'll do is just update that so it uses that app folder structure. So first thing that I want to do also is I'm just going to enable SWC minify. So that sort of matches before. And then I will set up this experimental. And what we are going to do is put app.dir, and we're going to set that to true. Okay, so now that that's working, if I just do a yarn dev, you can see TurboPack is up and running. You can see event initial compilation, so it's saying sort of 4 milliseconds or whatever. If I open up localhost 3000, you can see it says hello world. So my application is working there. And now what I can do, if I want to test the hot reload for a second, I can just change this. So rather than saying hello world, I can go hello. Now I'm going to hit the save, and then you will see the hot reload working. So save. And then you can see the browser's updated with hello. So it's fairly quick. It's a hot reload there. And then you can see it's given this sort of updated in however many milliseconds there. So let me just close that. And I can keep making changes. So I can just go hello, hello. And it's fairly quick, right? You can feel that hot module reload, right? It's super fast to sort of come back. So that's kind of feeling good. Okay, so that's working quite well. So if I just kill that for a second, one of the things you can kind of see there's this sort of initial compilation time for 0.7 seconds. You know, that's all fine. If I just clear this for a second, do an ls-la, you can see there is a .next folder. So if I just rm-rf the .next folder, because that's sort of used as a caching, and then if I do let's just clear that one more time, and then do a yarn dev again, you can see there it's sort of taking about 2 seconds or whatever. But if I open that up there, you know, you get that little just that little, do you see that little, takes a second to come up, that's fine. But now if I just run this again one more time, you can see it's super fast. And the reason it's super fast there is because if I do that ls-la again, you see that .next folder there is doing a little bit of caching. If I just remove that one more time, and then we just bring up yarn dev one more time, and then we just, we'll get rid of this, and we do the localhost kind of 3000, you get that, it's back again. So that is one of the nice things about TurboPack. It has a pretty optimized cold startup time, as you can kind of see there. But actually, after the cold startup, because it's got the you've got the .next folder and it's caching all those files, then every subsequent start there is pretty fast as well. Alrighty, so what we're going to do now is we're going to create that Vite app. So to do that, we are going to create in that same sort of top level folder a new app called Vite test app. So to do that, I'm just going to type in yarn create Vite. And then that's going to take a second there. So again, like the next create app, it's asking me for a project name. So we're going to call it Vite test app. Again, we're just going to use React, and then I'm going to use JavaScript rather than TypeScript, and then we'll keep the same things together. So let's just clear that. If I go into Vite test app for a second, you can see it's created a new folder. So I can do it code dot. And I can look at that within Visual Studio Code. So if I was to do a cold start on this one, first thing I could do is if I just do a yarn install, it will install all the packages that I need. And now if I do a yarn dev, you can see my Vite app is up and running. It's on localhost 5173. And you can see it's created a Vite plus React sort of test boilerplate app. What we're going to do is going to set it to the exact same component as we created earlier in our next app, and then we can start looking at how we can compare the two. So let's kill that for a second. We will kill this. We will go into our Vite test app here. What I am going to do is I'm going to open up, I'm just going to get rid of this public folder because I'm not going to need it. And then what I'm also going to do is I'm going to get rid of this assets folder. So next thing I want to do is I just want to clean up a couple of things in here. So you can kind of see that I'm using React and React DOM 18.2. I don't need the types in here, so I'm going to get rid of that for a second. And then I think we're probably good. We're matching versions between React on our Vite app, so we're all good. And now what I'm going to do is I'm going to get rid of this index.css because I don't need that. And then I'm going to get rid of the app.css because we don't need that either. And then I'm just going to change the app.jsx so it's the exact same as what we had before. And then we're just going to paste in here. So we have another function called hello. And then finally, if I go back into my main JSX, I'll get rid of that import from CSS, save that. And now if I open up 5173, you can see it's saying hello. So I've now got my Vite app and my next app both doing the same thing, which is returning hello. And then similarly, if I go back into my Vite app for a second here, if I want to change something in here, so I can change that hello, and then save that, and you can update it. And then you can see the hot module reload working as well. This is one of the first things I'm going to say here is I'm working with a single component. We're going to bring this up to about 1,000 components later on. But you can kind of see there's not a lot of difference, at least from a kind of visual perspective. If I make a change on there, it's not a massive difference. You remember that kind of pause there? So this is the first thing that I want to say about this kind of whole Vite versus Next comparison and being 10 times faster is there's not a lot, to a user, there's not a lot of difference there, right? It feels pretty fast. So we could be sitting arguing here and going, oh, well, you know, this is faster and whatever. But to the average user, especially for a small number of components, there is just not a noticeable difference, right? So don't be basing your choice of tool sets on what the perceived speed of these these build tools are, because there is not a lot of difference. So from a user perspective, if you like Vite, go use Vite. If you like Next, go use Next. Don't make it over this is faster than this, because you as a user is not going to be able to tell a difference, okay? With that speech out of the way, what we are going to do now is we are going to create a test harness. So the thing that I want to be able to do is I want to be able to measure the changes here. I need some way of measuring when I make a change to that page, I want that to be captured. So I'm going to take a pause for a second before we start building our test harness, because there's been a lot of arguments going on between sort of Vercel and Evan You. And Evan You is the creator of Vite. Evan's been trying to sort of recreate the test, and he's been saying that the test that Vercel did wasn't fair, and he had his own proposed method. That's fine. I'm not going to use either of their methods. I'm going to use my own methods, but I am going to reproduce the results that Vercel had with their test packs. But we'll come on to that in a second. A lot of you are probably going to be screaming out something at the moment before we're going to create the test packs, and we will cover this, is that there is a fundamental difference between what the Vite build has got and what the Next build has got. So by default in Next 13, they will be using server-side components, so React server-side components. So what you are going to see is that the component that I showed in the next version is going to be server-side rendered, whereas the Vite version that I'm showing there is client-side rendered, and that's important. So one of the things we will do as we move on and as we test the differences between the two is we're going to see the difference between CSR and SSR, but we'll probably level the playing field at some point, so that we're running both the CSR tests on both frameworks rather than a CSR versus SSR. The second thing that we're probably going to level the playing field is the, and Evan, you made a really good point on this, which is that by default, Vite is using Babel, but it can use SWC. Now, from a Next.JS perspective with TurboPack doesn't work with Babel, it only works with SWC. So if you make a change to try and use Babel there, then it's not going to work and it's going to say you have to use SWC. So technically, if I wanted to level the playing field on the test, then I could make Vite run SWC. In all honesty, what you're going to see is when I do the results there, it's not going to make a large amount of difference, right? Because you're going to see how Vercel got to their results versus how Evan You got to his results a little bit later. But you will see that in all honesty, it's not going to make much of a difference, and I'll show you that in a second. So with that out of the way, I am going to go and create my own test harness. So I need a way of measuring these hot module reloads. I want to do it in a way which is specific to the user, so it's kind of what you and I would feel rather than some technical sort of check that that Evan and Vercel is probably arguing about. So what I'm going to do is I'm going to create a little test harness using a tool called Puppeteer. Puppeteer is a sort of a way of doing a sort of headless browser test. And then what we will do is make the changes. So essentially the hot module changes that we're making just now, we will do that in our test harness, right? And then we will capture the timestamp. And then we will open up the test in the browser and we'll capture the change there. So all a little bit complicated. Rather than you sit and watch me type this out, what we're going to do is I'm going to do the old kind of Blue Peter here's one I made earlier thing, but I'll walk through the code that I've actually created for that. Okay, so in this test harness, I've got two files. I've got one called Vite.Js and one called Next.Js, right? Again, I will post this code up on my GitHub and then you can access it and you can run the same test yourselves. So what you can kind of see there is I've got something called edit component hello and I've got something called test HMR, and I'll explain that in a second. So what we're going to do, I've got one for Vite and I've got one for Next. So the Vite one, as you can imagine, is going to call test HMR, passing in the URL of the website that I want to access. And then I'm going to tell it to use the edit Vite component function, so which is essentially going to run this edit component hello on the following file name, so Vite test app source.jsx. So let me just run that through a second. There's a bunch of files there, but you will kind of see what's going on. So the edit component hello is really simple. All that it's going to do is essentially it's got a little template there, and all it's going to do is write out to the file that you pass. So I'm passing in the file name, and it's going to pass in this. It's just going to create a function that says hello and then pass in a timestamp. That's all it's going to do. and then it's going to write it out to the file that you've specified. So essentially, if you remember in my simple example that I did earlier, where I just created a little component that said hello world, all we're doing is writing that here. The key thing is I'm capturing the time that I did the write for where I started this function. And then after I've done the write of the file, I'm capturing the timestamp. And I'm doing it synchronously. So as soon as that file is written, I'm capturing the timestamp. And then I can use that a little bit later on. So that is what the edit component does. It is literally just writing out a nice little simple React component. That's all it's doing, and capturing the timestamp. Now, the second thing that I've got here is I'm calling this thing called test.html. What is in this at this point in time is I'm using a tool called Puppeteer. Puppeteer is a headless kind of Chrome browser automation script, so you can use it for essentially running automation on browsers. And then what we're going to do here is pass in a URL. You can see it's going to launch my Brave browser. I've got headless switched off. I'll switch it on for a second so you can see the browser, but basically I'm running it without a browser. So once we launch the browser, what we're going to do is go to the URL. So in this particular case, if it's Vite, it'll go to the Vite URL. If it's Next, it'll go to the Next URL. And then the key thing that I want you to see there is, and this is where everybody's probably going to complain about my method, etc., and say, oh, this isn't accurate for whatever. But basically what we're going to do, and this is similar to what a user is going to have, is like, we're just going to wait for a change on a div. All we're going to do is kind of do a reload. And then the key thing is that when I do that, all I'm going to do is I've got that timestamp. I've also got a timestamp from earlier from when I did the save. We're going to do a little bit of a calculation, and then it's going to tell us how long it took us from the time that we saved the file to that div being essentially changed. And then we're going to close the browser, and then I'm going to return that back. That is literally all that this is going to do. So what I'm going to do is I'm going to remove this headless part for a second so that you can see the browser come up. We'll run the Vite test. Yeah. And then once the Vite test is done, we'll do the same for the next test, and then I can sort of make that change. So let's come back into my test harness. So you can see my test harness is running essentially in the same folder structure as my Next test app and my Vite test app. So we'll just go into test harness. And then what I'm going to do is I'm just going to do a yarn, and then I'm going to do test and Vite. And just so you know why I'm selecting that, if you go to my package.json there's test for Vite. I'm doing a TS node Vite.TS. So all I'm going to do is call that Vite test app. So if I just run that for a second, you can see it opened up my browser. Let's go to that, and then you can see it's done this sort of hello, and it's captured the sort of timestamp for that. That's really all that's happening underneath the hood there. So again, if we now come back into, and you can see it's sort of saying it took about 10 milliseconds. So now that you know how that works, what we are going to do is we're going to come back into Visual Studio Code. I'm just, for easiness sake, I am going to take that headless piece off. And now if I run yarn test Vite again, you can see it's sort of saying it takes about 4 milliseconds or so, 11 milliseconds. So I'm getting various results, but you know, I mean, if I wanted to be really accurate about this, I could run sort of 10 results, do the average, etc. But I'm really just trying to show roughness on this one. So if we want to, we can run the same for Next. So if I come back into the Next.js, you can see all we're going to be doing is calling localhost 3000, and then this time we're going to be changing the Next test app as opposed to the Vite app. So if I were to run that, do yarn text next, it'll take a few seconds, and you can see it's coming back with about maybe it's about 18 milliseconds there. There's a bit of a difference there, you know, 21 milliseconds, right? So that's probably the starting point. I'm running a single component, but I want you to see the difference a second there, just to remember. You can kind of see that the same test is only taking about 3 milliseconds with Vite, whereas with the Next application, It's taking about 22 milliseconds. So I don't really need to run an average here. I can sort of tell that the Vite is running faster than Next. So that's probably the first pause for reflection here, right? Although I'm only running a very simple single component, the first thing I want you to see here is that Vite is running faster than Next. Now, the next thing you're going to go is, oh, no. But Next is running server-side rendering at the moment as React Server components, whereas Vite is doing it client-side. So you're going to say, well, you need to level up the test. You need to level up the tests. Okay, we will level up the tests a little bit. Okay, so if I want to therefore use React Server components and have it be essentially client-side, what I can do is, I'll do this manually first of all. What I can do here is change this so that it essentially has the prefix use client here, and that will tell Next.js that I want to use React Server components client side as opposed to server side, and therefore it's not going to be this sort of rendering up client side component server side. So if I do that, then and then I run that again, what you're going to see that it's going to use client side rendering for those components. So client side React Server components. So what I will do in this particular case is, rather than doing this sort of manually, let's just start that back up again, is what I'll do is change my test harness to make that work. So if I come back to Visual Studio Code over here, what I'm going to do is go back to my hello component that you've got here. But what I'm going to do now is I'm going to create a React Server component version of that. So we will just copy this because I don't want to change my my Vite version. And then I'm going to put this use client in here. We'll just say edit component hello, and we'll just say it's RSC, so React Server component. We'll add this here. We'll save that. And then I just want to export that. So we'll add that in as an export. So we'll save that. And then if I come back to my, this time to my Next.js, what I'm going to do is change that edit component hello to edit component hello RSC, and then we'll change edit next component so it's using RSC. So now what it's going to do is use the use query version. So if I were to now, so if I were just to run that again, what you're going to see there, it's taking roughly 20 milliseconds, 18 milliseconds. So it's running a little bit faster, but it's nothing too significant. It's a little bit faster, but nothing too bad. But if I come back to running my Vite version, you can hopefully see that the Vite version is running still significantly faster. So the first thing that I'm going to say, and this is not an exact test, and you're probably going to sit and argue and say, oh, well, the conditions are not the same, etc., and that's fine. But as far as I'm seeing here on a single component version, for a small amount of components, I would say Vite is running faster than Next is. Now, again, we can argue about my method, but I think it's close enough, right? So I think you can kind of see that that's working. Now, what we want to be able to do is, and this is one of the things Vercel kind of focused on, is they focused on kind of like 1,000 components and beyond. So what we're going to do now is we are going to try and reproduce the test that they did, and then see if we can reproduce similar results to that they had. So what we are going to do is we're going to download the test that they've got, which generated like 1,000 components. We'll use the exact same 1,000 components, and then we'll run it through the harness and see if we can get sort of similar results. So let's do that. So what we are going to do is I'm going to go into here, and what we will do is we are going to clone the Turbo repo from GitHub. So we'll go to git clone github.com vercel turbo.git, and then that will clone into my folder. Okay, so now that that's downloaded, what I'm going to do is I'm just going to cd into the Turbo source directory, and then there's a folder called crates, which is obviously got our Rust crates in there. And then what you can see here is there is something called TurboPack create test app. that's actually the test that they use. So that's actually creating a test app on their website. So if I bring up their website for a second, if we then click on the benchmarks, you can see the benchmark that they're using. They've got this little test generator where it's creating a Sierpinski triangle, and you can kind of see the triangle there. So that's actually the test that they're using. So let's see what this actually creates. So we will go into TurboPack, create test app, and if I actually just let me just do a cargo build for a second. So what that's doing is building the Rust app, and then what we will do is make a quick change, and then we'll see how it looks. Okay, so it's built the application, so let's just clear that. If I were to open that up in Visual Studio Code for a second, you can kind of see all the source code for this. So you see this, here's the main file, blah, blah, blah. It's a test app builder. And what it's going to do is output to my current directory. I'm just going to create a folder. I'm going to output it to a folder called output for a second. But if we open here, what you're going to see, hopefully, is it's going to start creating these triangle JSXs, and then it's going to start basically generating some components, which is going to create that Sierpinski triangle that you saw there. So what I'm going to do now is I'm just going to make my folder output, and then I'm going to do a cargo run. And you can see it is now should have generated in the output folder. If we just look at that, you will see that it has created a nice little test app. So you can see TurboPack test app. It's called Index.JS. And then if I go into that, you see app pages, there's layout, etc. Here's my page.jsx. And then what it is essentially doing is creating all of these kind of triangles there, triangle, triangle, triangle. And basically you've got, if we go to the triangle JSX at the bottom there, you can see it's importing triangle 1, triangle 2, triangle 3. And then if we go into triangle 1, it's doing triangle 1, 1, 1. So it's creating this hierarchy of triangles, and basically that's going to give you about 1,000 components. So now that we've got that, all I'm going to do is essentially copy all of that stuff, from my from that folder into my Vite app and my Next app, and then we will be able to do that. So what I am going to do is I'm just going to open this. And I'm going to, So what I'm going to do now is I'm going to grab every single folder here, except for, so what I'm going to do is grab every single folder apart from app, index, and pages. And that I'm going to throw into a components folder. So if we come back into, let's just cd out of here for a second. And then where are we? TurboPack, record. So we're going to sit on our top folder here for a second. We'll open up Visual Studio Code. And what I'm going to do in both in the Vite test app and in the Next test app is I'm going to create a components folder. So we'll just have a folder called components here. And then we will copy all of those files. In here. So we now got all of our kind of, So we'll just copy all of those files into our components folder. So let's just reveal in Finder here. So we'll just paste it in here. So that is in there, and then in the Vite app, and then we're going to do the exact same in the Next app. So we'll have a new folder called Components, and we'll paste that in here as well. And then the next thing that I'm going to do here is I'm going to get rid of this hello whatever, and then I'm going to just paste in the import, so import components triangle JSX into there in both the Vite test app and then in the Next test app as well. So if we come into page.jsx, we'll get rid of this as well. I will skip the use client for just now. We'll come back to that in a second. We can always bring that back in. So I'm going to paste that in here as well. But now, if I open up, let's start with the TurboPack app. We open up localhost 3000. You can now see I've got this big triangle thing, which is the same test that Vercel was using. So let's get rid of that for a second. And then if I do the exact same for the Vite app, and we just click in here, takes a second, and then you can see I've got the same triangle. So now I'm set up in the exact same way as I was before. So what I can do now is come back into my test harness. And then what I'm going to do is I am going to essentially import this triangle in here, right? So that piece of code that we had here, I'm now going to do a paste within there, and then you'll be able to sort of do the hot module reload. But this time we'll be able to capture it because we're going to be making changes using our new triangle code. So that's what this does. So this file is the exact same as it was before. So we're now going to move to using this sort of edit code triangle. And what I've done here is I've also created an edit RSC component triangle as well, so that we can use one or the other. So, but for just now, we will just use the edit component triangle before using the React Server component version. So I'm going to come back to Vite. And now, rather than using the edit component hello, I'm going to use the the edit component triangle. It's going to make the change to the same folder as we did before. And then I'm going to do the same to the next component. So rather than using the next using the hello component, I'm going to use the RSC component. We'll just get rid of that. We'll toggle this out. We'll put this in here. For just now, I'm going to use the edit component triangle. So we'll just get rid of this import. I won't use the RSC one for just now. We'll just use this. So that's going to use the edit component triangle. Just check the Vite one. That needs to use edit component triangle as well. And now, if I were to run my tests, so at the moment, remember, Next is going to be using server-side rendering just now, whereas Vite is going to be using client-side rendering. So if I do a yarn and then do my test Vite, you can see the HMR, remember, it was about 4 milliseconds before. Now that I'm running 1,000 components, it's taken close enough to somewhere between 40 and 50 milliseconds. So that gives us a rough idea that by running these deep nested components, and there's about 1,000 of them, all different levels, do you remember? you can see that it's had a massive effect on the hot reload time. It was 4 milliseconds. It's now up to sort of 50 odd. And you can kind of see that this is working. So if I let's just open up another shell here. If I just do a code dot on this in Visual Studio Code, and if I come back into my Vite test app, you can see there is the app that we created. It's got the triangle, etc. But then it's got all of that deep nested components, component after component after component. Yeah, so that's all the way that we want, and it's got lots of different folders. So that's how it's got to the kind of 1,000 components. So okay, that's fine. It's taken about sort of 50 odd milliseconds. So what happens if we run the next version of this? So rather than running Vite, we will run Next. And you can see it's running 36 milliseconds, 32 milliseconds. So the first thing I'm going to say here is that's not 10 times faster, right? And if I'm honest about this, if we come back to the Vercels benchmark page there for a second, you can kind of see the claim that they're making, right? So we're about the 1,000. You could probably argue this is kind of where we are here. So if I look at this one, Vite is in green, and then TurboPack SSR is here. So that's a clue as well. Vite CSR and TurboPack SSR. So they're doing this at the moment, whereas the green is going up like this. So, you know, in this case, it's saying, okay, this is a little bit faster. But when we hit the sort of the 20,000, 30,000 mark, you can kind of see there's a massive difference. So basically, this is going to get progressively worse. And actually, we can prove that. So if I remove some of the components, you're going to see that time in Vite, that time's going to come down. Whereas it's kind of fairly consistent. In fact, let's just do that for a second. So if I come back into my Vite test app, and then we look at these components here, let's store a copy of the original. So we'll call this components original. That's fine. And then let's say I decide, let's go into my triangle here. So if I just get rid of A and B, for example, and we get rid of this, what you're going to see is I'm going to drastically cut down the number that I'm running. And then if I just do yarn test Vite there, you can see it's taken 28 milliseconds, where it was around 50 odd milliseconds before. So you can see Vite is getting progressively worse as time goes by. So the more components that I add in, the slower and slower it's going to get. So actually, you can sort of take what Vercel has said there, and if I multiply it up to 20,000, you can imagine that's going to get sort of exponentially worse quite quickly. So I sort of get that, but remember what we said before? I'm running in SSR mode at the moment. What if I switch it to CSR on on Next? What do you think is going to happen? Well, let's find out, right? So I'm going to come back into Visual Studio Code for a second. What we will do is go back to our test harness, and what we're going to do here is if we come back to the triangle. What we're going to do is switch to this edit RSC component triangle. And it's basically the same thing, except it's going to do the use client as opposed to not to. So that's all we're going to do here. So I'm going to go back into my test harness for Next.TSC. So we'll just get rid of that. We'll use... so what we'll do here is rather than use an edit component triangle, what we're going to do is use an edit RSC component triangle. And then here, we'll switch that to edit RSC component triangle. Everything's going to remain the same. So now what it's going to do is use React Server components, but use client-side rendering on it. Let's see the difference that it makes. So I am just now going to go yarn test next. And we're going to do that again because I've just done the first render. 76 milliseconds. Let me just do that again. 76 milliseconds, 71 milliseconds. 72 milliseconds, 65 milliseconds, 70 milliseconds. I want to come back to the Vite, for example. So if I come back into my Vite code for a second, I'm going to put the ABCs back in. So this is back to where we were. And I'm going to run the Vite test again. This time it's going to be, so it's going to be the exact same components. So yarn test Vite, 54 milliseconds, 56 milliseconds, 65 milliseconds for next, 68 milliseconds for next, 74 for next. Vite, 55, 45, 55. So I think you will find I have recreated close enough the test. I've created my own harness, but I've used their same triangle thingy that they've used. We can argue about the methods that I've got, but they're comparable, but I'm using the same paths. I'm using Vite and I'm using Next. And I'm going to recap this for a second because I want to be really clear kind of what's going on. We can argue about the methods and we can argue in the final piece there. I haven't used SWC's compile. I used kind of Babel in the same way as we did before. And we're going to skip all of that side for a second. If I look at the claims that Vercel has made with TurboPack, they're kind of right, which is if I were to put on 20,000 components, if I was to run Vite client-side rendering versus Next.js TurboPack server-side rendering, then you will find that at 20,000 odd components, I can see that it will get progressively worse. I can see that, right? And therefore, I can make the argument that you would say, yes, it would be 10 times faster in that case. But if I come back to the 1,000 component level, which is a lot of components, right? And by the way, hardly anybody's going to be running 20,000 components. But if I bring it back to the 10,000 component, or the 1,000 component level for a second, yeah, again, Next.js 13 with TurboPack will run hot module reloads faster, yeah, than the client-side server rendering, right? That's fine. Client-side rendering, it will faster. But if I put them both to client-side rendering, Vite is faster. Yeah, not Next. Vite is faster. So if I make it on equal grounding, client-side rendering versus client-side rendering on Ghost, both cases, Vite is faster. It's not 10 times faster. Vite is actually faster. So for the hot module reloads. So we can sort of say, yeah, but then the default configs, the default for Vite is, and I haven't tested Vite server-side rendering. I don't know what the result would be there. But you can see that I've sort of proven the same results there. Now, if I bring it even lower, and because 1,000 components is even a lot for the average individual, right? Or the average project. If I bring it down to a smaller amount where I use one component, Vite is faster in all cases, right? You saw that at the beginning. So Vite was faster, whether it was client-side rendered or server-side rendered. On the Next.js side of things, Vite was faster regardless. So we can argue about it. Vercel is absolutely right. Their tests, and they were very clear, actually. If you look at the blog post, and they've clearly called out CSR versus SSR, but they've kind of, they've admitted doing the client side rendering test there, and you can see it in the code base. They haven't put the use query in any of the test bits. I've used their files, nothing else, and you can see it. So again, I'm going to come back to my point, and it's really a sort of argumentative point. I would say that in reality, Vite is faster. Yeah. In the edge case that you're running 20,000 components or whatever, even 1,000 components, where you're running server-side rendering versus, if you level the playing field, Vite is faster. If you're not leveling the playing field, then TurboPack is faster there. But I'm going to come back to what I said in the original, right? This is marketing machines fighting against each other, and that's fine. Go do whatever you want to do, right? But actually, TurboPack is a great product, and I do think it is great. It is super fast. Vite is a great product. Again, that is super fast. Stop fighting, guys. They're both great products. And for the average user, you shouldn't be comparing this versus that, even though we've just spent a whole video doing that, I get that. But you should just be looking at this and saying, you know what, from a user perception perspective, they're both as fast as each other. Use the tool that you prefer, right? But if you are thinking to yourself, I'm going to use TurboPack over Vite, because TurboPack's quicker, or I'm going to use Vite because it's quicker than TurboPack, you're kind of crazy. But anyway, back to the point in this video is Next with TurboPack 10 times faster than Vite? No, not in reality. In a specific edge cases where you have a non-level playing field, yes. But if you level the playing field, no. Anyway, hope this video has been useful. And thanks to the person who left it in the comments. There was somebody in the comments that said, hey, I'm not sure about these tests. Chris, can you go and have a look at it? Hopefully, this helped. Anyway, I'll catch you in the next video. Speak soon.